Look at configuring FactoryTalk Links browser. So to begin with, you come over here and you right click on this icon, click on yes, and it's going to open this FactoryTalk software from Rockwell Automation. The first thing I want to check is that the second line here, click on this arrow, and all you're trying to do is verify that you can see the PLC, and it's at IP address 192.168.1.30. This is the model number of the PLC. And then we can expand on that as well. I do this by clicking on that arrow that points inwards, and again, wait a few seconds, and then it opens up all of the modules that are connected to the PLC. And it's important to note that there are different slots. These are called slots, and the first one is 00, which is the actual processor, 01, which is the discrete or digital I/O. So this is where the digital input and digital output connect to. Slot 2 is for the analog I/O, and notice it's called embedded because that means it's built into the actual processor. Slot 3 is for high-speed counter. 4 and 5 are for measuring temperature from RTDs and thermocouples, and they are on slot 4 and 5. There is also something called a panel view. That's an HMI that's connected. And the .180 is actually the IP address of the PC that we're connected to because we're interfacing to Ethernet devices. And this PC happens to be CA219B-01. All right, so this is an indication to me that everything is fine. If it wasn't, one of the things that we might go through here just to verify that everything is working properly, because if it didn't find that IP address, one of the things that we can do is actually delete this interface. So I'm going to right click and delete this driver configuration and then reinstall it. So delete, yes, and you notice now it's removed from that list. So now I can click on configure drivers, and we want to add a new one. So click add new. And the important thing to change right away is change this to broadcast, leave it at local broadcast. And I'm going to change the name to what it was so that I'm not changing things. And it was called Alan Bradley _ Ethernet IP-1. So once you've done that, click apply, but there is a second step. You have to go to advanced tab, click on this line here. The RD9700 is actually a USB to Ethernet interface that's connected to the PLC so we can access this IP device. It's been set to 192.168.1.180. That's actually done automatically using DHCP. And as well, you want to turn on listen to Ethernet IP. Once you've done that, click apply, yes, okay. And then you can actually close this window. So I'm going to click the X. And you'll notice that now it appears up here again. We'll just open it up. Make sure that we see the 192.168.30. Fine. We click on that. And we click on the PLC again. And there's kind of definite proof that this PC can communicate with that IP address device. So everything is working as expected. So great. So let's move to the next step. All right, in this next step, we're going to look at programming Studio 5000. So here's the icon that you have to click. You don't necessarily have to run this in administrator mode. Once this opens up, you click on New Project. So this is going to be a new ladder logic project. Click on that, and it opens up this new project screen. And here you want to click on Logix. Okay, and then I have to select the processor family. And for the machine that we have in the lab, that processor family is 5370. And then I have to select the particular model, and for us it's this 1769 L24ER QBFC1B. Now if you look up this number, it'll tell you the details about this particular embedded processor, but for now we're going to select it, so make sure that it's highlighted, and I'm going to call this Demo 2, and you have to put a name there. If you don't, I don't think it'll give you this next button highlighted, so we do that. And here we don't really have to change anything other than you might want to put your name in here. Okay, which I've done, and maybe even the date. So May 10th, 2022, and maybe even the lab number. But once all that's set up, that's all you need. So we have this CompactLogix 5370 controller. Once that's done, click on Finish. And eventually a screen will pop up. After a few seconds, this screen does pop up, and this is the main screen that we're going to be working with. And this is where you'll find the controller organizer. This is a really good place to look up information that's required while you're programming. So I'm going to click on the main program. This little arrow means that there are other things that you can look at. I'm going to look at the main routine. And here we have our starting point for our ladder logic. And it always has an end command, that's second rung. And I have my first rung, rung number 0. If I want to add a comment, and it's good to do that, you would right click on rung 0, click on edit rung comment. I'm going to put my name up here, and probably a good idea to put the date, May 10th. And whatever lab you might happen to be working on, you'd put there as well. So once you've done that, you can just click that OK button, and it'll have that comment there. Very useful to put on every single line. And we'll start off with just creating a simple test program that doesn't connect to any hardware, but just to show you how things work. But another step that you should probably do before moving on is to set the path. And this is the area that indicates the path. And right now there is no path. And what the path indicates is when we download or transfer this software, it indicates the IP address of the PLC that it'll transfer to. So I'm going to select this icon here, and you can see it selects the communications path. And right now, there isn't any path, so I'm going to click on where I want to go to. And remember, we set this up in FactoryTalk links. This is the processor right here. This is slot 0. You want to make sure you're just highlighting the line with the IP address, the 192.168.1.30. Once you've done that, you select Set Project Path. Okay, and now you see that path appear up here. So it tells me that it knows where to go to when I want to download a program. So I'm going to start off with 3 different versions of a program. I'm going to start off with a simple one. I'm just going to bring in 2 examine if close instructions, 1 output energize instruction. I'm going to give them a name, just a tag name. A tag is like a variable. So I'm going to call this switch 1, switch 2, and light 1. And let's create a second rung. Okay, so add a rung, and if you want, you could copy this, but I'm just going to move this down to here, here, and you'll notice that you can place the objects when the little green dot appears. And I'm going to change this to light 2. Okay, and I'm going to leave these at switch 1 and switch 2. Okay, now that we've got all that set up, you want to make sure that you have identified those variables as to what data type. Because right now, if I were to check this program by clicking on the Verify Routine, you would see that there's a whole bunch of errors, 3 on rung 0 and 3 on rung 1. And those errors are indicating that I have an undefined tag because I haven't specified what data type it is and whether it's an alias tag or a base tag. So I have to do that first. So you just right click on the text for the name, new switch 1, and all you want to do here is confirm that you want to use a base tag, and I'll explain that a little bit more later on. It's part of the main program. It'll appear as a decimal data type, and it's a Boolean. That's probably the most important part. Boolean is indicating that it can only be a true or a false. So once I do that, I click on Create. And now if I hover over that variable or over that instruction, you'll notice that there's no error there, whereas here it's undefined. Very good to hover over variables to let you know what's happening. So Create, That's great. And light 1, new light 1, I create it, mostly just verifying that it's Boolean. There we go. And now this rung, the second rung, well, let's see what errors it has. So I'm just going to do it again, and there's only one error. It's only that light 2 is undefined, and that's because we already defined switch 1 and switch 2. So they're not causing the error, but over here, this one's causing the error. So I do new light 2, it's Boolean, and create. Everything seems to be okay. So now to test it, I always click on this verify routine. Students don't tend to do this as often as I do, but it saves me time because I don't have to download to realize I have an error. It's a 1-second click, and I know that I don't have any errors. So the next step is to come over to where it says offline, click on download, and I always am looking down here to see if it's connecting, if it's ready. So everything seems to be ready. So download. Okay, all that seems fine. And there we go. Okay, now if I want to test this program out, or if I want to make a change, and actually I didn't want the program to look like this, so I'm going to make a change. So I'm going to go offline, and I'm going to make a change. I actually wanted to make a branch here. And now I can drag this instruction into the branch, this instruction to the branch, and notice things go green, means you can place them there. And what I wanted to do is show the difference between ANDing on that first line and ORing on this second line. And these are both examine if closed instructions. They will go true whenever the instruction is true, and both of these being true, just like an AND gate, will cause the light to come on. Either of these, an OR, will cause light 2 to come on. So let's download that again. Or we can just do a quick check, no errors. Let's download. And here we go. And downloading is the process of moving the program that I have on the computer to inside the PLC. And once it's in the PLC, it stays there. It'll only go away if you remove the power, but even if you turn the power off and then back on, it's stored in a non-volatile type of memory. So you don't actually lose it until somebody else overwrites that program. So this program doesn't connect to any hardware. These are just base tags, but I can test it. There's a simple way to test my software here. So I'm going to right click on this, toggle this bit, and you'll notice that that bit has these little green bars to the left and right indicating that instruction is true. And it happened in both places. So since one of these, since this is an OR type of instruction, caused light 2 to come on. And this one's only going to come on when I toggle both bits. Okay, and the light come on. The light came on, proving to me that the AND operation worked as expected, the OR operation worked as expected. So make sure that you're in run mode, the controller's okay, IO is okay, and you're in remote run. One of the ways you'll know right away that you are in run mode is that there's a green bar here and here. Okay, so that tells you everything is working okay. Now I want to show you another area that you can go to see the status of the bits, the instructions, and so on. So I'm going to toggle this bit first. So light 1 is on, light 2 is off, switch 1 is on, switch 2 is off. Well, this is the line where my main routine is located, but the one just above it is one that gets overlooked a lot, but it's very important. It's where all the tags that are created are located. And you can see here that I have light 1, 2, switch 1, switch 2. It's a data type, and the values are indicated here. So light 1 is currently a 0, light 2 a 1, switch 1 a 1. So it's a good place to kind of verify that the variables that you've created are there and they exist. And this is a demo for Studio 5000 Part 2, in which we're going to work with controller tags and base and alias tags. So a little bit of each. So I'm going to start off with a very simple program. So I'm going to add a new rung. So you do that up here. And I'm going to bring 2 instructions down onto the rung. They're both examine if closed instructions and an output energize. The next step is that I'm going to give them a tag name. So I'm going to call this over temp, and I'm going to call the other one over pressure. Okay, let's put two S's there. So I have over temp and over pressure, and over here we're going to call this alarm. Okay, and these are just names that I want to use for that variable. But now what I want to do is tie them or link them to a piece of the hardware. And that hardware happens to be in slot number 1. Slot number 1 is where I have all of the digital I/O. So I come over to the variable again. I right click over the name, okay, not in the instruction, but over the name, and say new over temperature. And then I'm going to change it from a base tag to an alias tag. So I'm saying that over temperature is going to be linked to another variable. And in this case, it's a variable, it's in the hardware. And so for our controller, so this is our controller, we're going to connect it to local 1 input. So it's the input module. It's not going to be the data, or sorry, it's not going to be the fault, but it's going to be the data. Now the data is broken down into 16 bits of input. So I have to use this pull down to select bit. I'm going to select bit 4. And then once I've done that, I say create, and it actually shows me that tag down at the bottom. So the bottom one is the base tag, over temperature is the alias. I want to do the same thing with over pressure. I'm going to link it to number 4. Because I have switches connected, those real hardware switches. So it's going to go to local 1 input data and bit 5 of that data. And once I've done that, create, and the alarm is going to go to a blue light. So alarm, alias, and it's going to go to bit 0. Bit 0 actually connects to the blue light. So I've done that here, and it's going to go to bit 0. And then I'm going to do create. Okay, so I have my program set up the way I want. Next, I'm going to download. So come over here, click download. And download is that process of moving the program from the PC to the PLC. And once you're done downloading, you want to make sure that all of the places that should be green are green. That tells you that you're in run mode and there are no errors. Okay, it takes a little bit of time. Down here, check that it's completed, no errors, and you do want to go back into run mode. So let's just do for some verification. 3 green lights here, green one here. The 2 bars are green as well. So the program is running, and it's indicating here that over temperature and over pressure are true. This is an examine if closed, so it's true. So one of the things that I can do here that's kind of neat is I have the ability to check this remote PLC. It's actually connected to the PLC in CA219B, and I actually have a camera pointing at the I/O. So I can see here in my input, and my inputs are these switches, PB0 connected to bit 0, 1, 2, 3, 4, 5, 6, and 7. You can't see those 2 at the bottom, but I know the switches are open. So these 2 switches are closed. Okay, and I can't change that. I'm remote, so I can't physically change that. We could, I guess, create a project to move those switches remotely. But it's showing me that local data 0, this green push button, is off or open. This one is closed, this one's open, and 3, 4, and 5 are all closed. Okay, and that's why my program, when these 2 switches close, that light comes on. I could have switched it to an or I could move it to a different switch, and you'll see how it responds. So let's just see if we can make a change to our program. So we come back over here. I'm going to go offline. And what I'm going to do is change this instruction to data 6. And I know that that switch is closed. So I'm going to right click, or actually I think you can double click, and you can change that to examine if off. But I'm also going to change the bit. I'm going to go to bit 6. So let's do that. So I go edit pressure properties, and actually I can just go to that box and change it from 5 to 6. And I know that 6 is off. But this is an examine if open instruction. So that switch is open and it should go true. Now, be aware, because right now we're not connected, we're not online, so don't rely on what you see for as far as the green and not green on the instructions, because it's not valid right now, not until we download it. Okay, here I go, I'm downloading this. And download that instruction. And as I said, so on the left is an examine if open. Okay, and this is an examine if closed. So the open, I might have said that wrong, sorry, let's go back. This is an examine if closed. This is an examine if open. So if this switch is closed, the instruction goes true. If this switch is open, the instruction goes true. And I know from looking at the controller tags, if I look at bit 5, it's closed, and bit 6, it's open. Okay, these are the state of the switches, the actual physical state of the switches. And these are the addresses. Okay, so it's made up of 16 bits, so all of the 16 bits combined together, if you look at the number here, this is a 16-bit number. These ones are the ones where the switches are closed, the zeros are where the switches are open. And then it's broken down into binary here. And you can switch it from binary to decimal. Okay, so that's 58 decimal. You can switch it to hex. That's 3A and hex. And you can convert that hex to binary. So this is 3A. So the 3 is made up of the 1, 1, that's a 3. And then 1, 0, 1, 0, that's an A. Back to the main routine. Okay, now we can add a second line. If I wanted to add a second line, I'll go offline, right click, add rung, and here I'm going to put another examine if closed, examine if open, but I'm going to add a branch. I'm going to put these into the branch, and I'm going to add another light. We can call it motor. Okay. And motor, we're going to give it an alias, or sorry, motor is the alias, and it's an alias for a tag that we're going to use an output this time. It's going to be data 2, and I think that's a green light, or data 1. We'll use data 1. Create, so everything's there, and I'm still going to use over temperature. And the neat thing here is if I want to search for it, you can see that the tags are already there, so I can just click over pressure. And if I double click and use that pull down window, you'll see that over temperature is there, so I don't have to rewrite it. And then we're going to download that. And the top instruction is an AND type of operation, and the bottom one is an OR type of operation. So our program is running, and we're connected to 4 and 6. Now, this can indicate that 6 is open and 4 is closed. And that's why this motor doesn't come on. So let's try making a change. One of the interesting things that you can do while running your PLC, so without stopping it to make changes, and that's important in industrial situations sometimes, is that I can edit the program and modify it while the other program is still running. So let's see if we can do that. So right click and click on Start Pending Rung Edits. And what you get is 2 different lines here. One that indicates the running program and the one that we're making changes to. Okay, so this is the one that we want to make changes to. So what I want to change is I'm going to click here and change this to examine if open. Okay, and you can see that that's done. But the program, this top program, is not the one that's running. This is the one that we're editing. This is the one that we're still actually running. But now that I've made all the changes that I need to make, okay, I can say accept pending rung edits. Okay, so I've accepted those edits, and now you have to click on this button here is to finalize. And what's going to happen is it's going to switch over from the bottom 2 lines actually being executed, they're still executing, to the top 2 lines being executed. So it's kind of telling you that there's some warnings here that you're going to make those changes. Finalize all edits in the program. Yes, I do want to do that. And now it's switched over to this program being executed. And what it allowed me to do is to change that instruction kind of on the fly as I was modifying the program. And now I can go back to my camera and see that I have output 4 turned on and output 5 turned on. The other thing you might want to do that's kind of very useful, and let's see if I can do it while it's down here. So here I actually have my program running, and these are all my inputs. And you can see that local 1 data 0 applies to this top light. That's actually 0. So the out 4 is for the bottom one, out 0 is for the top one. It's being cut off there. And I can't modify or change that video position. And 1 is this one. So, sorry, data 0 for the input is this push button. Data 1 for the input is this push button. Data 4 and 5 are these 2 switches. And 6 and 7 are these 2 bottom switches. 4 and 5 are on, and 6 and 7 are off. And 0 is off or open, 2 is open. So it tells me how all the hardware is located. Now that's for local 1 input, but I can switch over here to local 1 output. And I want to see everything in binary, so I'm going to move this window over a little bit. Okay, maybe I have to move this whole window over to see what I want to see. And so I want to take all of those bits, and now I can see all of those bits. And you can see that, oh, here we go. Local 1 output data 0, it's equal to 1. Data 1, it's equal to 1. Now, the program is controlling these 2 bits. So here's something kind of unique. So if I try to change this, what do you think is going to happen? If I change that variable from a 1 to a 0, didn't even change it. It's because the program is controlling that. Now here, same thing. If I change that to a 0, the program overwrites it. But data 2, okay, this orange or yellow light is not being controlled by a program. So I should be able to come into here, change that to a 1, and the light comes on. I can go to 3, change it to a 1, light comes on. I can go back to here, change it to a 0, and the light goes off. Okay, I'm sitting at home and controlling this PLC remotely. And this is very common in industry. You don't have to go to the factory to change something. You can do it from home. Now, that sometimes might be an issue with security. So you have to make sure these things are secure. And that's one of the reasons we have that FactoryTalk tied to the remote machine with your computer name. So now that we've done that, we can go up here. We can actually go up here and on the main program line, right click on it, go to Properties and Configuration. Okay, Properties Configuration. And there's a little box here that says Inhibit Program. And this is very useful for troubleshooting hardware. Very, very useful. So get used to working with it. But if I click on that Inhibit Program, what it does is it stops the program from controlling any of the outputs. That way I can manually control the outputs. Very, very useful for troubleshooting. Now it's very important that once you're done with the Inhibit Program mode to come back and turn that off. Okay, so now the program is running, but it's not controlling these outputs anymore. It's just staying to whatever level the outputs were at before. So now I should be able to come here and change that to 0. And it controls out 0. Okay, don't be confused with it saying out 4. This is reference to the bottom light. If I want to turn on that light, I can do that. So I can turn it on and off. Very useful in troubleshooting, for example, the solenoids when you're doing lab 1 in the instrumentation lab. And once I'm done that, okay, and you'll see that I can turn this off, and I'll actually turn off the other one. Okay, so I've turned off both lights, but I'm inhibited. I'm not actually running, I'm not controlling those lights anymore. Okay, you'll see, and that's what's a little confusing here, is these are both indicating that they're on, but the alarm is off. Okay, and that's because I'm in Inhibit mode. This is actually showing me the state of the outputs. But now, if I come back over here to the main program and click on Properties, what you'll see here is that going back to Configuration, turn that Inhibit mode off, and as soon as I turn it off, bam, okay, it's now the program is controlling those lights. Okay, very important. And as I said, you can go to the controller tags and have a look at what's happening. These are my input tags. Local 1 input data 0 to 15. I can click on my output tags or just scroll down and it sees all of the outputs that are on. Another thing that comes up once in a while is students say, well, why is this light on? I didn't turn it on. It's not part of my program. Well, if some other program controlled it to be on, well, it's going to stay on until something else turns it off. So if you have that issue, one of the things you can do to get around it is I can just come in here manually, turn it off. Okay, turns off that light, and then I can do a save. I can save that program so it doesn't make changes anymore to what I want to do. Okay. So let's stop at this point here. Hopefully this will help you with lab number 1, okay, or 0 if it's the PLC Labs. Hopefully all of this helps. If you have any other questions, send me an email. Thank you.